pin down the minister on this, but neither his department nor our own department, DEFRA, have really yet appreciated that this is the land-based sector can make a substantial contribution to national energy needs, and that diversification into renewable energy in embracing multiple technologies is really a very important opportunity to support profitable farming. We want to keep farmers on the land. We don't produce food very competitively in Europe. We know this. This is why we have common agricultural policies, this is why we have single farm payment. But it is strategically very important that we keep farmers on the land for food production, but also for other public benefits in terms of landscape management, maintenance of biodiversity and so on. So farmers have increasingly been asked to help with those goals as part of the price for supporting them and keeping on the land. And yet, the Common Agricultural Policy wants to reduce its budget. Here is a possible opportunity, at least, to replace some of that agricultural support, make sure that we can have our members engaged in profitable farming. And we made this part of our campaign goals recently, talking about how, yes, farming can deliver clean energy production, along with many of the other things that it does for the countryside. So here are Rooftop, top left there, Michael Eavis at Glastonbury, one of the first really large dairy barn PV arrays. One on the top right there is in David Cameron's home constituency. These things really complete no-brainer, and it is good now that we do see more talk about large-scale rooftop schemes on commercial and other types of SME buildings apart from just agriculture, and the government at least talking about how it would like to offer a little bit more for building integrated PV. So on-site needs clearly important, and this is where we get into this rather interesting MIDI scale. This demonstrates in rather Jack and Jill terms how we don't really need public subsidy at the margin. This is very simple, very basic ROI, simple return on investment, but you can see that depending on quite how much of the energy you can be displacing on-site at a retail price, what you would otherwise be paying, say 10 pence per kilowatt hour or £100 a megawatt hour, this is already offering better return in a low interest economy than keeping the money in the bank. And then the government's going to give you a cherry on top. Now, this is only at the margin. Relatively few people are in this fortunate position, but it does transform the economics, and I think this is why this sort of MIDI scale, where a lot of the power can actually be used on site, is important, not just for agriculture, but for many other SME applications as well. Now we move on to look at the large scale stuff. Now this is Adam Twine down near Swindon, before and after. We've seen some good examples. These 2011 installations, like the one we visited yesterday down at Burnagullo and so on, they're starting to mature up nicely. They're starting to look good. We've set reasonably high standards of practice already, I think. But what is the role that government is going to give us for doing this in its strategy? Certainly it can look ugly in other countries where there is no visual mitigation, where it's put in really prominent positions. And it can frankly look pretty science fiction-y indeed. Clearly these are tracking arrays on a desert site in the United States, but we don't want to scare people with this kind of imagery. And many people have already said, yes, this engagement with the local communities is somewhere where we've got to learn from the experience of the wind industry. It can be done through good design, it can be done through other forms of visual mitigation. Good security fences, hedgerow planting around hedgerow restoration, retention and clearly of all existing trees and what have you. So these kinds of things, we replace hedgerows, we create new native woodland, we do little engineered things like wetlands or a new bit of woodland planting down in an unusable corner of the field. We can put bat and bird boxes all over the place. And yes, public amenity, this can enhance public access to land in some cases. And we have these guidance documents we're talking about now, and the new one now from the National Solar Centre. But a lot of this started really here in Cornwall with the old draft planning guidance that was out already in 2010, 2011. We then had the engagement of some of the government staff at Natural England who produced their own technical information note. One or two developers are getting in problems again now with Natural England, who've sort of moved on, sacked all their original policy staff, and in the hands of the local Natural England enforcement people, there seems to be a misunderstanding again of what position the government's own competent authorities are taking on this. We can look to other countries, and there's a very useful report which is downloadable from the German Renewable Energy Agency. And I think some people are starting to look to us now for more guidance on what we actually mean by these terms like best and most versatile land, the land that we would like to retain as far as possible, as a national strategic reserve for food security, the land that is best for cropping as opposed to grazing and things that may well be compatible with solar energy deployment. What is the meaning of these rather vague and not very fine-scale agricultural land classification grades? 1, 2, and 3A are what we call best and most versatile land. 3B, 4, and 5 are the lower grade land, often at the moment just used for grazing and certainly suitable. Sheep grazing tends to be the sort of default thing that planners are expecting. 1 or 2 asset management people still are not terribly happy with the insurability of sites with sheep grazing. A lot of this is going to be engineering solutions, having good armoured cables, everything tucked out of the way, perhaps increasing the height of the leading edge of arrays as deployed. Silage cutting, so you're not actually putting livestock in the field, but you're still using the fields to produce good quality grass silage, which can be essentially mowed and then taken out of the fields. You're going to be using machinery to do that. And you've got to think about issues of stone thrown from the mowing equipment. You've got to think about the issues of collision with careless machine operators who perhaps are trying to do this at the end of a very long day. Environmental management sounds really very low risk compared with this. All of the stuff that we were talking about earlier on, including the sort of thing that local wildlife trusts or bodies like the RSPB will be calling for. They want to see perhaps undersowing with winter forage mixtures that provide birds with a winter source of seeds that are retained on plants. Or we're looking at nectar and pollen mixtures, which can bring in pollinating insects, some perhaps rare, some more simply as an economic service to a farmer who may be growing a crop quality grape in the field next door and would really like to have a good reservoir of pollinating insects in close proximity. The sort of things that we can be talking about though, and perhaps now that we've got a little bit more policy certainty, we can move and plan and build at a rather less frantic pace. It certainly doesn't help when the tariff changes on the 1st of April and we end up having to do a lot of the construction and final building work over the winter season when the land may well be less freely draining. But measures can be taken using low ground pressure vehicles, a lot of guidance out on this kind of thing for other purposes. We shouldn't be bringing road vehicles with road tyres onto fields. You must have controlled access, traffic access, you must have good project managers on site. Avoid soil compaction, avoid as far as possible that damage to the land drains in the farmland. Think about, yes, it's time limited, it certainly is an important part of our public perception, whether or not you end up getting an extension to permissions and operation beyond 25 years. It is ostensibly time limited, and so you should be thinking about how land restitution, putting back field drains, repairing some of the damage done during the installation, will take place at the end of the project life. We've seen mistakes with people taking out soil for trenching and then putting it in backwards, so the farmer will have a lovely stripe across the field in perpetuity. That can easily be avoided just through good practice guidance. Thinking about this idea of solar stewardship, we're looking after agricultural land for a limited period of time. We're putting in all these interesting other features, and then yes, at some future date it could go back into the National Land Reserve. Now here's the interesting stuff. This is what you wanted to hear, I think, from me. Bioenergy, in terms of government planning for future renewable energy supply, is really majoring on the land use, up to 4 million hectares. That's the max that DEC have been thinking about in their what's called their 2050 pathways analysis about how the low carbon transformation can take place. Now, we have ourselves looked at figures out to the end of this decade, and we're talking about roughly a 1 million hectare land take. Half of that in transport biofuels. Primary food feedstocks diverted if they're not going for animal feed. And certainly a lot of the stuff from last year's harvest, very poor quality grains, can't be used to make Weetabix, so it goes for animal feed or it goes into ethanol processing. But that's all largely hidden because we don't see fields looking any different. Certainly, perennial energy crops look different. Things like willow and miscanthus, those are government policy goals. There is an expectation that the government's got to do a lot more to develop these supply chains to support biomass-fired power stations. Otherwise, we're going to be completely dependent on imports. We're going to see Drax and some of the other large coal conversion power stations, Tilbury in Essex, Ironbridge, Eggborough. These things are going to be producing 5 to 10% of UK electricity within about 5 years. And it would be ridiculous if all of that were dependent on imports. So, alongside that, and alongside our own stated goal, Greg Barker talked about anaerobic digestion and the desire by the government to see more of this deployed on farms. That has to be also supported by these rotational crop feedstocks, grass, silage, beet, whole crop maize. We're talking up to 100,000 hectare land take for that. So, based upon typical solar farm land take, 20,000 hectares supporting 8 gigawatts, frankly sounds quite reasonable. 20,000 hectares is just 0.2%, 1/500th, ladies and gentlemen, of the land which is classified as lower grade, 3B, 4 and 5, which is about 50%, 58% of all agricultural land. So I think we can strike this balance between food production, energy services from the land, other non-food production, construction materials and so on, low-carbon construction materials, as well as environmental and heritage management of land. These are not mutually exclusive. Now, more numbers. What this basically says is that, look, biomass has probably got the greatest land take of all, but a biomass power station producing 20 gigawatt hours a year, or the needs of about 5,000 households, would take 1,800 hectares. It would give you some heat as well, but it is 1,800 hectares. Same amount of electricity from biogas, which is essentially a higher metabolizable energy-yielding crop, comes down a bit, it's about 1,200 hectares. If we want to produce that electricity with onshore wind farms, well, we don't actually use the land apart from the footprint of the foundations, but it certainly does have quite an extensive impact in terms of land take. Probably 250 hectares or so based upon typical turbine spacings, typical sort of technology in use today, with agricultural or wildlife amenity land use in between the turbines. You've still got to look at the turbines. Right. Solar farm, same thing, 60 hectares. I rest my case. This is impressive. We can quantify this, we can go to the minister and say, come on, we're pretty efficient about getting energy from the land. We're pretty efficient at harnessing these renewable natural resources that are incumbent upon our British Isles, and so we have the least impact. The reality, of course, we actually need all of these things. We need the schedulable, storable, dispatchable power, as well as the intermittent renewables. But nobody can accuse us of wasting resources or being inefficient in the way that we deploy. So I think I'll pretty much conclude there. We do have these substantial renewable natural resources in the land-based sector, and we continue to say these can be used either for export or they can be used for on-site power. We don't want to see farming as some sort of sector that's a pathetic victim of the vagaries of weather. We've had some horror stories of farmers digging sheep out of snowdrifts, farmers who couldn't get off their land last year, had terrible harvests and so on. But I think as we see the cost of agricultural solar PV continuing to fall in cost, whether we're putting it on roofs or whether we're putting it on the land, it really is just a question of how large we can set our ambition. because sooner or later, without subsidy, as we approach closer and closer to grid parity, it's just going to be the planning system, it's going to be grid access, it's going to be the advent of new technologies like on-site energy storage, which will limit us. So 11 gigawatts, 10 terawatt hours, which is what I predicated this around, now sounds a little bit out of date given what Ray was just saying earlier. Thank you very much.